We did long division, and so I think you're going to find that synthetic division is so much easier than long division. The only thing is it can only be used on certain types of problems. So we still need to know how to do long division, but synthetic division is definitely preferable when it's possible. So synthetic division, synthetic kind of means man-made. I'm not really sure where the word synthetic division comes from, unless it's just kind of shorter. So it's what we would call a shorthand division. Shorthand is a style of writing that stenographers use in court. Now, it only works when you're dividing by what we would call linear factors. Now we learned what linear means. It means that it's x to the first power. So something like x plus 1, you could use it for that. X minus 3, and so on. So if it's just an x and then a constant, we can use synthetic division. It makes it really nice. Okay, so there are some steps for synthetic division, and I want to go over these. I'm going to read over them. But then on our first few examples that we're going to work, I'll also have these steps there too, because it's a lot of steps. It looks a whole lot more complicated than it is. It really isn't that complicated. Okay, so the steps. Step 1, you're going to list the polynomial's coefficients, and that's of each term. That's the dividend and the divisor. And then you're going to use 0 as a placeholder for missing terms, kind of like we did a little while ago. Place the value of the factor, the x-intercept, inside a box. I'll show you how to draw it and everything. Number 3, drop down the leading coefficient. Number 4, multiply the leading coefficient by the value in the box and place the product under the next coefficient. Number 5, add the next coefficient to the product. This sounds so complicated. Number 6, repeat steps 4 and 5. Number 7, rewrite the polynomial with the solution. Note the solution will be 1 degree lower than the original polynomial. Now let's get started. Let me show you how easy this is. So see, I've got them all up here. So we're good. All right, so I have a linear divisor. Anytime you see a linear divisor, you can use synthetic division. So if I have a linear a factor, so if this is a factor of this, which is really what I'm trying to find out. I'm trying to find out if 2 is a root, though. So if this is the factor, then the root would be 2. So the root that I'm looking to find out if it's a factor, this is what I'm going to use in the synthetic division. So here's what I'm going to do. I'm going to take this x to the 4th minus 3x squared minus 10, and I'm going to look and see if I need some placeholders, which I do. I need an x to the 3rd. So I'm going to need a 0x to the 3rd and a 0x as placeholders. So I'm going to put this 2. I'm going to use 2. So just like when we do roots and factors, we're going to use the opposite of what this is. So I'm going to use the actual 2. And I'm going to put the 2 over here. And then I'm going to list the coefficients of the dividend. So I'm going to list, well, there's a 1 right here. Y'all know if there's no coefficient shown, it's a 1. So I'm going to list 1, which is the x to the 4th, 0, which is the x to the 3rd, the negative 3, make sure you include that, negative 3, 0, and negative 10. So I'm going to write it just like I would write it up here, but without the x's. All right, so then I'm going to put a bar or a line down here. I need to leave space for some numbers right here because there are going to be some numbers right here. Okay, so let's see. We've done steps 1 and step 2 so far. Okay, we put the root, the value of the factor, we've put it in a box, and we've done the coefficients. Now we are always going to bring down the first coefficient. That's going to be right there. Okay. Then what we're going to do is we're going to multiply this root times this coefficient. So we're going to multiply 2 times 1 and put that here. Okay, so 2 times 1 is 2. Then I'm going to add or combine this number and this number. So combine this Just add them. Okay? Then I'm going to multiply again. I'll multiply this times this and put it here. 2 times 2 is 4. Then combine -3 and 4. -3 and 4 is 1. Then I'm going to multiply again. 2 times 1 is 2. 0 and 2 is 2. Multiply again. 2 times 2 is 4. -10 and 4 is -6. Okay, so here comes the kind of the trick. I always draw a line right here because this last digit, this last number right here is my remainder. Okay, so I mark that with an R. And then you know how you've got x to the fourth, x to the third, x to the second, x to the first, and then constant. So this is my constant term. Well, this is my constant term in my answer. Okay, this is my x term. I'll just go backwards. This is my x squared, and this is my x cubed. You're always going to have 1 degree lower than what you started out with. So your answer is going to have 1 degree lower than your original dividend. And that's what that says right there. Okay. Okay, so here's my answer. I go from left to right, 1x cubed, or just x cubed, plus 2x squared, plus 1x, and I can just write x, plus x, plus 2. And then my remainder is minus 6 over my original divisor, x minus 2. So this is the answer, which also, because there's a remainder, tells me that 2 is not a root of this polynomial. Okay, if it had been a root of this polynomial, we would have had a 0 right here. So that's a lot. It's a lot of steps and it's a lot to remember, but it's much, much easier than writing this out and trying to do that long division. Let's try another one. Okay, so let's see first if we have anywhere that we need a placeholder. We do. We have right here, we need a 0x squared. So now we have 4, 3, 2, 1 constant. So that's what we're looking for. Okay, so x plus 2 means that the root that I'm looking for is -2, because it's always the opposite of that. So I'm going to put my -2 in this little box here, and then I'm going to start listing my coefficients. This coefficient is 1, so I'm going to list 1, list them in order, 2, 0, 2, and 4. Draw my line down here, and remember my last term that I get is going to be my remainder term. Okay, so always bring down the first coefficient. Bring down that 1, and then start multiplying. -2 times 1 is -2. Well, 2 and -2 is 0. -2 times 0 is 0. 0 and 0 is 0. -2 times 0 is 0. 2 and 0 is 2. -2 and 2 is -4. 4 and -4 is 0. So this is my remainder. This one is always the remainder. This one's the constant, so just go kind of backwards. Remainder, constant, x term, x squared term, and x cubed term. Again, this is going to be 1 lower than this. Okay, where I have zeros, I don't even have to write those, so I can forget about those. My answer is going to be x cubed plus 2. I don't have a remainder, so that means -2 is a root of this. So let's write that. -2 is a root because I don't have a remainder. Okay? All right, let's try another one, and we'll still have the steps up there. Do I need any placeholders? Let's see, I've got 4, 2, 1 constant. So yes, I need a 0x cubed. Okay, my factor is x minus 3, so that means the root, or what I'm going to write in the box, is positive 3. So let's put a positive 3 here. And then start listing coefficients. I've got a 1, a 0, a 2, a 3, and a negative 2. Okay, put my line down here. This is the one under the negative 2 is going to be my remainder if there is one. If there is a remainder, that means 3 is not a root for this polynomial. If there isn't one, if it's 0, that means 3 is a root. That means it is an x-intercept. It crosses at 3 or touches at 3. All right, let's bring down, see, number 3, drop down the leading coefficient. Drop this down. And start multiplying. 3 times 1 is 3. 0 and 3 is 3. 3 times 3 is 9. 2 and 9 is 11. 3 times 11 is 33. This is going to get big. 3 plus 33 is 36. And then 3 times 36 is 108. Negative 2 and 108 is 106. Okay, so this is my remainder. This is my constant. This is my x term. This is my x squared term. And this is my x cubed term. You could write them right there. You could write the x cubed there and the x squared there if you wanted to. Okay, so I'm going to start here. 1x cubed, I would just write that x cubed. 3x squared plus 3x squared plus 11x plus 36. And my remainder plus 106 over this right here, x minus 3. Okay, so that's the answer. Again, the 3, 1 lower than the 4. Okay, let me see. I didn't put the steps on this one. Give me a second. I'm gonna go get those steps. Put it here. Okay, so I got the steps up here just so we can refer to them if we need to. Let's see. I want you to try to set this one up and then pause the video, set it up, and then come back and see if you set it up correctly with the number in the box and then all the coefficients and everything and then the line. So do that first and then restart the video and see if you got that. And then I want you to try to solve it while you have the video paused as well. So pause it and see if you can set it up first. All right, so this is what it should look like after you set it up. Now I want you to pause the video again. Oh, let's just talk about this for a second. If the factor is x plus 2, then the root is negative 2, and so that's what goes in the box there. And then you didn't have a placeholder because you had 5, 4, 3, 2, 1 constant, so you didn't have a placeholder here of 0. And so you're going to bring down the negative 5 and then start multiplying. So I want you to do that and see if you can get the correct answer with the remainder. So this is going to be the remainder right here. So remember, you go remainder, constant, x, x squared, x cubed, x fourth. So you should start with an x fourth right here. All right, pause the video, see if you can get it. Okay, this was a long one, but it certainly wasn't like it would have been with long division. So my final answer was negative 5x to the fourth plus 8x to the third minus 19x squared plus 39x minus 80 plus 159 over x plus 2. And because there was a remainder, I stated here, negative 2 is not an x-intercept for this polynomial. All right, let's see if we have another one. Okay, we have 2 more. All right, so without the steps being there, which those steps are so long, without the steps being there, I want you to see if you can set this one up and solve it. So pause the video and come back to it. Let's see. let's just go over this. You've got a 6, a 5, a 4, a 3, a 2, a 1, and a 0. So you don't have any placeholders that you need. So you don't need to do that. Oh, excuse me. Your root is going to be -1. So remember, -1 is what goes in the box. Okay, see if you can get it and come back. Okay, so you should have set up your coefficients as 3, -1, 2, 3, 1, -2, and -1. And then the -1 goes in the box here, bring down the 3, and so on. And you should have gotten this green answer as your answer. And you can see we did have a remainder of 5. So we put that over x plus 1, which having the remainder of 5 means -1 is not an x-intercept. Okay, one more, and I want you to try this one. Let's see if we need any placeholders. We have 6, 5, 4, 3, 2, 1 constant. And nope, we don't need any placeholders. Pause the video, see if you can set it up and solve it, and then come back. All right, so the green part is your answer. I want to make sure that you understand that you need to copy down all of this work, though, not just the answer on this, if you didn't actually do the work while the video was paused. So we had, this is the answer, and this was the remainder, and so we put that over x plus 2. Because there was a remainder, that means -2 is not an x-intercept. All right, so that's it for synthetic division, and the end of lesson 7. We have one more left in this unit. Let me know if you have any questions on this or on your assignment.